Okay, we have a ballistic motion problem here. It's a threshold problem, so we're going to have to answer the yes or no question, which means that at the end we're going to be looking at some kind of yes or no question instead of necessarily solving for a quantity. Well, let's get started. So we've got some kind of ditch here, and a ball is kicked from one edge with an initial velocity v0 of 8.5 meters per second, making an angle of 23 degrees above the horizontal. The two edges of the ditch are at equal vertical positions and 6 meters apart horizontally. And we want to know if the ball makes it to the other side of the ditch. Okay, so since this is ballistic motion in 2 dimensions, I'm going to consider the x and y components of the motion and write down what I know and what I don't know. If you haven't already done this problem, this is a good time to pause the video and fill out this table for yourself and then see if you agree with me. Okay, so I don't know how far it goes. I know that the initial x velocity is 8.5 cosine 23, and the initial y velocity is 8.5 sine 23. I also know the final x velocity is 8.5 cosine 23 because the x acceleration is 0. Right? I'm using a sign convention that up is positive and to the right is positive. You can tell that by how I wrote down my initial velocity, right? The y acceleration is negative 9.8, right? It's 9.8 meters per second squared in the downward direction. And I don't know the time here or here. One other thing that I know, and this is a little tricky, but I do actually know the y displacement, right? The ball has to begin at this level of the ditch, and it has to end on the other side. Whether it falls short or makes it, our analysis is going to end when it returns to the same y coordinate, and so delta y is 0. So I actually know 3 things in the y direction, which means I can solve for the other 2. I'm going to go ahead and solve for t. Let's see, so delta y now this is going to turn into a quadratic, unfortunately. However, because the delta y term is 0, this turns into a relatively easy quadratic. I can factor out a t here. And so this quantity here is equal to 0 when this argument is equal to 0 or this argument is equal to 0. That occurs when t equals 0 or t equals 0.678 seconds. Now, if you're not a big fan of quadratics, you could solve for the final velocity, right? You could say that, well, vy squared is equal to v0 y squared plus 2a delta y. And of course that term is 0, so vy is just plus or minus v0 y. So vy is minus 8.5 sine 23. Right? And then you could use that and say, well, okay, vy is equal to v0 y plus at, and you could solve for t that way. You can get the same answer. You get 0.678 seconds. Right? This answer that we got over here reflects that the ball is at the coordinate y equals 0 at t equals 0, and it returns to that coordinate, that altitude or that height at 0.678 seconds. Well, anyway, now that we have time, we can figure out whether or not the ball makes it over the ditch. Right? Now the ditch is 6 meters across, but notice that I did not put 6 meters as my delta x, because I don't know that. Right? I don't know that this thing returns exactly to 6 meters. I have no idea how far it goes in x. I don't know if it falls short or if it makes it over. Our delta x is unknown, so we're going to solve for delta x, and then we're going to compare it to 6 to answer the question. So I'll use this equation for delta x. So delta x is equal to 7.82 times 0.678 plus 0, because the x acceleration is 0. So that's 5.3 meters. And since 5.3 meters is less than 6.0 meters, it falls short.